Hey, it's Mr. Allred here, and we're going to talk about radicals and rationals. And the topics I have on deck here are solving radical equations, which will be in this video, and the following videos will be simplifying rational expressions, solving rational equations, and then we're going to graph rational functions. So let's start with radical equations. And radical equations are equations with a variable under a radical or a root. So kind of like a square root or a cube root, if you will. And we need some steps to solve these, and they'll work very nicely once you see some. And I'll explain why, but the first step is we're going to isolate the radical. So if there is a root, we're going to get it by itself, meaning on one side. We're going to try and get rid of that root by raising both sides to a power, because we can do the same thing to both sides. Then we'll have an equation without a root, hopefully, so we can solve it. And our method kind of forces us to check our answers, not as an option, but as a necessity. So just kind of keep these four steps in mind. Isolate, then we're going to raise to a power, we're going to solve and check. So the first one we have here as an example is the square root of 2x minus 5, and then plus 4 equals x. So as I suggested, the first thing we want to do is get the radical by itself. So the radical is the square root of 2x minus 5. So I need to move that 4 to the other side. So when I do that, I will have the square root of 2x minus 5. And then as I move the 4 to the other side, there'll be equals x minus 4. So I want to get that root by itself, because the next step I'm going to do is, because it's a square root, square both sides. And I have to do both sides to keep it equal. Remember, I could add the same thing to both sides, multiply both sides by the same thing. So I can also square both sides and keep the equation equal. So when I do that to both sides, squaring the square root will cause it to cancel out. If it's not by itself like it originally was with the plus 4, if I squared it then, it's a FOIL. And if you actually write out that FOIL of the original left-hand side, you'll still have a square root, so it doesn't help. But squaring this left-hand side, I get 2x minus 5 because the root cancels out. Now in this particular one, be careful on the right-hand side, because you're squaring x minus 4, which is also a FOIL. That's x minus 4 times x minus 4. You don't just square both terms. So as we multiply that out and collect like terms, I'll get x squared minus 8x plus 16 on the right-hand side, which looks an awful lot like a quadratic equation. So let's get everything to one side. Let's move the 2x minus 5 over to the right-hand side. So we'll have 0 equals x squared minus 10x plus 21. And we have some factoring techniques we can use here. But it breaks down as we factor this thing into x minus 3 times x minus 7. So that's two factors multiplied together to equal 0. So we can set each one equal to 0. X minus 3 equals 0. X minus 7 equals 0. And the two solutions this gives me is x equals 3, x equals 7. So let's kind of backtrack and make sure we see everything we did. I started by isolating that root by moving the 4 over. And then to get rid of the square root, I squared both sides. So then I have a normal quadratic type equation, which I went through and solved. It could be a linear equation, it could be something else. But after I get rid of the root, the hope is that it's something I'm familiar with. And I got two answers, 3 and 7. But we need to check these. So let me kind of off to the side here explain why I need to check these. So keep in mind, I could write any two things down that I want. I could say negative 2 equals 2, which is a completely false statement. So I've got this negative 2 equal to 2. which does not make any sense. It's not true. But if I do what I did in this problem and square both sides, it turns into 4 equals 4, which is true. Okay? So what we're seeing here is the reason we need to check our answers is when we squared both sides, we may pick up extra answers. Okay? If there's solutions to this equation, we're going to get them, but we also might get something extra. So let's check. But that's the reason why. So let's check x equals 3. So if that's the case, we'll say the square, we're going to go back way back to the beginning. Square root of 2 times 3 minus 5 plus 4 equals 3 when I plug it in. So let's see. So that gives me 6 minus 5 is 1. So in the end, this thing gives me 5 equals 3. No good. So this does not work. So let's go down here and mark this 3 out. All right. So now let's check 7. See if it gets any better. And it's possible if we get 2 answers for one of them to work, both of them to work, or neither to work. All right, let's go back. All right, square root of 2 times 7 minus 5 plus 4 equals 7. Let me clean up that multiplication there because it looks a little weird. Let's see here. If we clean this up, we'll have 14 minus 5, which is 9. Square root of 9 is 3. So this thing balances out to be 7 equals 7. And that works. So this one here works. So when we get down here, the x equals 7 is the only one that works. Okay. Let's try a second example. But that's why we must check, because we can accidentally get answers we don't want. All right. This one here is the cube root of 4x minus 1, and then minus 2 equals 0. So let's go through the same procedure. Let us move the 2 over to the other side. So the root is by itself. So cube root of 4x minus 1 equals 2. And since this is a cube root, let's cube both sides. Let's clean that up a little bit. And when we cube both sides, it will cancel out the cube root. So 4x minus 1 equals 8. 4x equals 9. X equals 9 fourths. If I did everything right. So let's check that as I suggested. So let's check. X equals 9 fourths. We probably shouldn't have this problem with an odd root, but we may. Let's see here. So we're going to say the cube root of 4 times 9 fourths minus 1 minus 2 equals 0. So let's see here. 4 and 9 fourths, they can't, the 4's cancel out. So basically we got 9 minus 1. So as we clean that up, we've got the cube root of 8 minus 2 equals 0. Let me clean that up since I made a mess. And it's true that the cube root of 8 is 2, so 2 minus 2 equals 0 works. So it checks. So this answer works. Just to highlight that, we got one answer, it worked. Okay. But we did the same thing. We isolated the root. We, in this case, cubed both sides and then solved. And then we checked our answers. So we did all 4 things that I had listed out. The last example I'll do here is the square root of negative x plus 30, and then plus 3 equals x. So my first step, to get that root by itself, so get this root by itself. So that means subtract 3 from both sides. So I'm going to get the square root of negative 2x plus 30, and that'll be equal to x minus 3. Okay, so the root is by itself. That's step 1. Step 2 is to get rid of the root. It's a square root, so I'm going to square it. Square both sides. Squaring the square root gets rid of the root. So 2x plus 30 on the left. Squaring the binomial, the x minus 3, creates a FOIL, which was, collect like terms, would be x squared minus 6x plus 9. Once again, we're going to move everything to one side, but the root is gone, so now we're just trying to solve. So x squared minus 8x minus 21. Let me think about that one for a little bit. It looks a little weird. I believe I've done everything correctly, so I'm trying to think. Things that give me 21 are 3 and 7. And I don't see that combination, so I'm a little bit worried here that I've messed something up. Let me pause it and think for a second. Okay, I can't go backwards in time in the video, but here's the problem I've got. When I squared the square root, hopefully you caught it, but it should have been negative 2x plus 30. So, that's going to change things when I bring the 2x over. It'll be adding 2x, so it looks like I'll have a negative 4x. So, bringing the quadratic all to one side, I'll have 0 equals x squared minus 4x minus 21. Okay, I can see that's going to be a little bit better because I can go through my factoring a quadratic technique, and I will get x minus 7 times x plus 3, which is two equations. X minus 7 equals 0. X plus 3 equals 0. So the solutions I'm picking up right now are x equals 7 and x equals negative 3. But we talked about the fact that we should check these. So let's check x equals 7. So when I plug that in, I'm going to have the square root of negative 2 times 7 plus 30 plus 3 equals 7. So let's see. That'll be negative 14 plus 30, so that'll be 16. So on the left-hand side, I'll have 4 plus 3 equals 7. That works. So we get to keep the 7. And then with the other one, we will check x equals negative 3. So we will plug it into the original. We have square root of negative 2 times negative 3 plus 30 plus 3 equals negative 3. So I get under the square root 6 plus 30, so square root of 36. So I get 6 plus 3 equals negative 3. Not true. This means does not work, the negative 3. So I'm just going to mark it out. I'm going to mark it out down here and just kind of highlight the one that did work, which was the 7. So we want to make sure we clearly state the answers that work and get rid of the ones that don't work. But the solving technique may pick up more than we really want, but it will always give us the answers we want as well. Okay.